Alright guys, today we'll be looking at direct current electricity. And we have a question here. We have a circuit diagram. We have the current, the resistors, everything there. We have the voltages here. And we're going to be using Kirchhoff's law to answer this question. It says calculate the current I1, I2, and I3. Part B of this question number 1 says determine the voltage drops across R1, R2, and R3. Let's look at the solution here. Solution 1A. What we are going to calculate I1 first. Okay, according to Kirchhoff's law here, the current that is entering the junction, and this is first law, is equal to the current leaving the junction. So this is a junction here. Alright. Now we have I1, current is going this way. As you look at the arrow, it's coming this way. We have I3 coming this way. So I1 plus I3 should be equal to I2. According to Kirchhoff's first law, I1 plus I3 equal I2. Because the current entering the junction is equal to the current leaving the junction. Now let's identify something here. What direction in this first loop is the current moving? What's the direction? Is it clockwise or anti-clockwise? Now, looking at the arrows here, you can clearly see that the current is going in a clockwise sense. So we can indicate here, okay, the current is going this way, this way, this way, and this way. So the current is going in a clockwise sense. Looking at the next loop, the current actually is going in anti-clockwise sense. Current is going like this. From this source, it's going this way. Let's indicate that. It's very important to always indicate the direction of flow of the current using Kirchhoff's laws. So the current is going this way, coming this way. Okay. So in this loop, current is going in a clockwise direction. So you don't have to write it there, just write it so that you can remember that. In this loop, the current is going in anti-clockwise direction. Okay, anti-clockwise direction. Now, let's look at the first one. If we consider the loop A, B, F, G, A, we are considering the first loop here. So 58 volts is equal to the current multiplied by the resistance, I1 multiplied by R1 plus I2 multiplied by R2. We're going to remove the SI unit so that we can solve and get our values later on. We give the SI unit. Now, 58 equal, in the place of R1, the value of this resistor is 4 ohms. So our 4 times I don't know the value of the current. Plus the second area here, R2 is 3 ohms. So in the place of R2, indicate 3 ohm times I2. We call this equation 2. Considering the next loop here, B, C, D, F, B. This loop, we say the current actually is coming from this source, this voltage coming like this. So 10 equal I2 R2 plus I3 R3. The value of R2 is 3 ohms. So multiply that by I2 plus the value for R3 is 2 ohms. We multiply that. Then we call this equation number 3. From equation 1 here, we're going to make I3 the subject of the equation so that we can substitute it and get our value for I1. So we have I3 equal I2 minus I1. So substituting this into equation 3 to this equation now, it becomes like this. So we have 10 equal 3i2 plus 2. Now, this 2, after the 2, the I3 is equal to this value. I3 is equal to I2 minus I1. So we insert that here. From there we bring it down, bring 10 down here. We bring 3i2 value, we multiply these 2 by the parentheses, we get this value. After that, we're going to simplify it, collect like terms, we add. So 3i2 plus 2i1, we got 5i2 minus 2i1. We call this equation 4. Solving for i2, using this equation, we have i2 will be equal to 10 plus 2i1 over 5. Just simple. We just hold this 5i2 here as a positive number. We send this 10 and we make this positive. So if you do the other way, you flip the equation, will still be the same. Now I1 over 5. If we substitute this value, I2 value, into equation 2, we can't. No, this is equation 2 here. So whenever we see I2 to this equation, we put this value 10 plus 2i1 over 5. So we have 58 equal 4i1 plus 3. In the place of I2, we have 10 plus 2i1 over 5. Then, of course, this side is a fraction, so we're just going to multiply this 5. Everything here, and multiply this 5 by this value here by 5, so we cancel. So here we multiply 5 by 4, we get 5 times 4, and 5 by 58, we get 58 times 5. If we do that, 58 times 5 is 290 equals 4i1 times 5 is 20i1 plus, now we're going to multiply the 3 the values in this particular parenthesis. So 3 times 10 gives us 30. We have a positive here, so definitely we have a positive sign right here. So 3 times 2i1 plus 6i1. Now, we have to collect like terms. We have 290 across the equation here, and here we have 30. So we have the same, the 30 across the equation again. And if we do that, we're going to subtract because it's positive here. Now we sum out 20i1 and 6i1. If we add them together, we get 26i1. Then we find the difference here over 26 or 260 over 26. Why? Because we are finding the value of i1. In this case, we divide this side by the coefficient of i1 and also divide that same coefficient that is 260. So when that happens, we simplify it. Our answer for i1 is 10